So question 11 is a galvanic cell question, and what we're looking at with the galvanic cell is this entire thing here. Sorry, let me get a brush here. This entire thing here is a galvanic cell. Now the first thing we need to do, and I'd recommend doing this first, just assign these as the letters that they are. So I is going to be Q, J is going to be Q plus, K is going to be R plus, and L is going to be R. The other thing that we're given here are these reduction potentials. Now, being reduction potentials, they're always going to take this kind of form. So Q plus an electron gives Q, and the voltage there is 0.200 volts. R plus giving R is going to be 0.600 volts. Now these are both reductions because the electrons are on the reactant side. That's important. And if you look at any reduction potential table, you'll see that that's where the electrons are going to be. Now one of these needs to be turned into an oxidation. The one that gets turned into an oxidation is always going to be the one that has the smaller reduction potential. That's because when we add these two together, after we flipped it, we need to get a positive value. So you'll see what I mean by that in a second. We're going to flip the Q, so the Q is going to go to Q, goes to Q plus an electron, which becomes minus 0.200 volts now that we've made it into an oxidation. We're going to do the same thing with we're going to leave the R the way it is, and it's going to just be 0.600 volts. Now when we add these together, that becomes 0.400 volts, and it's going to be positive. The fact it's positive is the most important thing here. Now the other thing we can do is make some statements about what these things are doing. So for this particular reaction, we know that it's an oxidation because we have to flip it around from the reduction. We know it's the anode, and we also know that because Q is becoming Q plus, that it's going to be dissolving. Now the other reaction is a reduction. It's the cathode, and it's plating. Now the reason I say it's plating is because it's going from R plus over to R, which is R solid. Alright, now we can answer some of these other questions that are over here. First of all, direction of flow of nitrate. Now nitrate is going to flow from the one that doesn't need nitrate to the one that does need nitrate. So what I'm saying here is that the Q here is becoming Q plus, so it's going to need nitrate. The R plus is becoming R, which means it's not going to need nitrate anymore. So it's going to travel from the R side over to the Q side. That means it's going to travel in direction C. The species being reduced. Now according to what we've got here, the only, I'm going to complete this reaction down here. We'll make it R plus Q gives Q plus R. And what we're going to see is that it's only these reactants here that can be possible as answers to what's being oxidized or what's being reduced. But the R plus here is being reduced to R. So that's going to be the answer is going to be K for that one. Now the cathode. The cathode is always an electrode. Now the electrodes are these guys right here. They're the bits of metal that are stuck into the solution. So the only answers that are possible are going to be, for that one, is going to either be I or L. In this case, the cathode is going to be where reduction is occurring, so we're looking at R as being the answer to that, but R is actually going to be the answer L here, because that's the R electrode. The direction of electron flow. If you look at these equations here, you can see that Q is turning into Q plus plus an electron, while R plus an electron turns into R. So what that means is that Q is actually giving up electrons and R plus is accepting them. So electrons are traveling from the Q side over to the R side. And the electrons always travel through this wire here that joins the two electrodes. You'll also notice that as a rule of thumb, the electron flow is the opposite of the nitrate flow because they have the same charge. So the direction of electron flow then would be B. I'm going to skip oxidizing agent for now. We'll come back to that at the end. The species being oxidized. Well, the species being oxidized, as I said, has to be one of these reactants that I'm pointing out here, R plus or Q. Q is the one being oxidized, so the answer is going to be I for that one. Oops, put it in the wrong place. There we go. The direction of flow of Q plus. So we've got to decide here what's going on with Q plus. Is Q going to be dissolving or is it going to be plating? Now per what we have over here, we can see that Q is dissolving. So if Q is dissolving, it means that it's turning into Q plus, which means I'll choose F as my direction there. It's flowing away from the Q electrode. I'll get a reducing agent in a minute. The direction of flow of R plus. Now according to what I've got here, R is plating. So R plus is turning into R, and that means that the direction will be G. So R plus will actually be flowing towards the electrode so it can plate. So the answer there is going to be G. The anode. The anode is going to be where oxidation is occurring, and according to what we've got here, we've got Q, which is going to be I. So the anode has to be I here. The only other possible answer would have been L, but we've already got L as being the cathode, so I is the answer there for the anode. Now the oxidizing agent and the reducing agent, these are two of the more harder ones to do, but what we know is this, that whatever's being reduced we'll say species reduced. That is going to be the oxidizing agent. And the species being oxidized that's the reducing agent. Alright, let's look at the oxidizing agent. When we talk about the word agent, what we're talking about is something that's causing an oxidation. So what is being oxidized here? Well, the Q is being oxidized into Q+. But what's causing that? Well, the fact is that the Q is turning into Q++ an electron, and then something is accepting that electron. And that something is going to be R+. So that's the species that's actually being reduced here. So the species being reduced is really the oxidizing agent. And that would be, in this case, K. The reducing agent. The reducing agent is the species being oxidized. Now Q is being oxidized into Q+, plus an electron. And what that means is that is actually causing the reduction of R+ into R by donating that specific electron, which is also this electron here, and R+ is being turned into R. So it's effectively, Q being oxidized is effectively reducing R+. So that means that Q is going to be the reducing agent. And the reducing agent then is going to be I.